are going to our next practice set, that is practice set 2.3. Okay, we have nothing but here called as the completing the square method. Now we learned so many types of methods. We learned the formula method, we learned the normal factorization method, we learned elimination by substitution method. Now this is a new method which we are learning, the completing the square method. In this method, see, there are totally 4 steps. The first step, if you want to take it down, the first step is standard form. Whatever equation will be given to you, first you have to bring it in the standard form. And what is the standard form? Ax square plus bx plus c is equal to 0. That is first. Okay. Then your next step, after you bring the equation in standard form, you have to convert the coefficient of x square. You have to convert the coefficient of x square to 1. Now what does this mean? Suppose your question is 2x square plus 3x plus 5 is equal to 0. Coefficient of x square is what? 2. You have to convert this to 1. How will you convert this to 1? Just erase and write 1? No. You have to divide throughout by this same term. Then only you will get 1. Why? Because 2 upon 2 is only 1. Nothing else upon 2 is equal to 1. Okay. So now you cannot only convert 2 upon 2 1. You have to convert all this. By converting means what? You have to only see to it that here there is 1. Here and here you don't need to have 1. But you have to divide throughout by 2. Then only it will make sense. You just cannot convert 1. According to mathematical logic, you cannot write upon 2 only here. You have to write upon 2 throughout in the entire equation. Okay. So if you see what this equation gets converted to, x square, sorry, 1 minute. So this equation gets converted to x square plus 3 upon 2x plus 5 upon 2 is equal to 0. Okay, let this be 3 upon 2 and 5 upon 2, no problem. Our main goal is to turn this into 1x square. So your second equation, condition was what? Convert, write it down, convert the coefficient of x square to 1. Then the next, third one. Now completing the square method. Completing the square method means, why we do completing the square method? There are many type of sums where we don't get the answer by factorization method, or we don't get the answer by any other type of method. That's the reason we use completing the square. See, and basically it is called we don't get the answer in factorization method. So suppose if you have sum, suppose, okay, if you compare this only, 2x square plus 3x plus 5. If you see, you have 2 5 is equal to 10, product is 10, and the sum is 3. Okay, just see the original sum. Forget all this 2, 2, 2, 2. 2 5 is 10 and 3. Do we have anything, any factors? We have 5 2s are 10, but 5 minus 2 is 3. So we'll have to have 5 and minus 2. But 5 into minus 2 is not positive 10. So it's like we are not getting factors for this. Such type of equation where you don't get factors, we use the completing the square method. And in completing the square method means what? We have to find the third term. What is the meaning of finding the third term? In this equation, if you see, we have first term, second term. Okay, this third term is not matching with this equation, because if you see 2 5 we are getting 10. Suppose there would be some other third term, then we might get the correct answer. Suppose it should be minus 5, then 2 5 would be minus 10, then we would get, no, 5 minus 2 is minus 10, and 5 into minus 2 is minus 10, and 5 multiplied by 5 minus 2 is 3. So we have to, our main goal is to find the third term. Once we get the new third term, then we can solve the equation. And what we do is to find the third term, to find a suitable third term so that it becomes a complete square. To do that, we equate the equation. Equate the equation means the original equation, that is 2x square plus 3. This is an example. 2x square plus 3x plus 5. We equate this equation with x plus a the whole square. Now what is this? What is x plus a the whole square? This is your a, and why I have taken a? Because in your equation there is ax square plus bx plus c. I could have taken b also, I could have taken c also, but the reason I took a is because the a term is missing. I divided throughout by 2, no? Okay, so a term is missing. I removed this and made this coefficient 1. That is the reason we equate this with x plus a the whole square. So a third step is to just write it down. Equate with x plus a the whole square. Okay, write this three steps. When we do a sum, we will understand this perfectly. Then now we assume. Now suppose we do x plus a the whole square. Assume, right? Last step is assume third term to be nothing but k. We assume it to be k, and then we solve and find the answer. That's all. First, convert it to standard form. Second, convert the coefficient, that is this part. Third, equate with x plus a the whole square. Why x plus a the whole square? First, it is completing the square method. That's why square. And x is already a variable here. Why a? Why not b and c? Because this coefficient we have removed. In the second step, convert coefficient of x square. So this coefficient we have removed. That's the reason we replace it and write here a. And the final step. Suppose now we have to find the third term. So we have to do an assumption. Let the third term be equal to k. So and we solve and find the answer. Okay. So now we'll just do one sum. Then you will understand this clearly. Let's take your practice set 2.3. Let's take the second sum. Okay. Second sum. X square plus 2x minus 5 equal to 0. Now if you see in this sum, already your first term, that is your coefficient of x square, is already 1. Correct? Your coefficient of x square is already 1. So and plus this is already in the form of ax square plus bx plus c. So your step 1 is already done and your step 2 is already done. If you see, this is the way a sum becomes easier. Step 1 over, step 2 already over, because in the question it is already in the general form, plus this is already, the coefficient is already 1. So till here, if you understood, please give me a thumbs up. Please give me a thumbs up if you understood till here. Step 1 and step 2 is already done. Please give me a thumbs up. Okay, say yes. Not thumbs up not working, then say yes. Fine. Okay. So step 1 and step 2 is already done. Now we directly go to step 3. What was the step 3? Equate this to a coefficient, equate this to your x plus a the whole square. Okay. Now what we have to do is very, very important. Let us compare this equation first. According to this comparing, what we get, a equal to 1, b equal to positive 2, c equal to minus 5. Okay, before that, I want everyone to solve this sum. Just write this question and do it with me. Write this question. When you are done, please type yes in the chat box. We'll do it step by step so that you all don't need to do this sum once again for your homework. Do it with me. Write this question down. Write the exercise. Practice set 2.3. Write this question down and please type yes in the chat box once you are done with it. Okay, all done. So now if you see in this equation, our first step is done, second step is done, third step and the fourth step is remaining. Now in the third and fourth step, as I said, we have to find the third term. Why we have to find the third term? Because this third term is not matching our sum. If you see, we will not get factors for this. First of all, there is no product, and if there is a product, there is a prime number. That is 5 1 is 5, 5 minus 1 is not 2, 5 plus 1 is not 2, so no factors for this. So we don't need this third term at the moment. Okay, let's equate this to x plus a the whole square without this third term. X square plus 2x is equal to x plus a the whole square. Now, as I said in the fourth step, this third term we don't want. See, we need this later, but as for this equating, we don't need this third step. Now, as I said in the explanation, what I was doing, this third term is not matching our equation, but we have to find a third term because the third term only complements and the third term only completes a quadratic equation. So let us assume the third term to be k. Okay, as I said, it was in the fourth step, we assume the third term to be k. Third step is x plus a the whole square, we equate it, and the fourth step is let us assume the third term to be k. Now if you solve this, this remains as it is. We cannot find any answer of this term. We can open the bracket here. What is a plus b the whole square? Zara, please unmute and tell me. A plus b the whole square is?
A minus b and a plus b.
Oh my God.
I
Lovely answer, Zara. Superb.
A square minus b square.
Oh, no. Zara has to practice a lot of formulas. Robert, unmute and tell me fast. What is x plus a the whole, sorry, a plus b the whole square? A plus b the whole square is equal to what? This is a formula you have done in the 8th standard, 9th standard. Robert, tell me fast.
A square plus b square.
You are also talking rubbish. Who knows? Those who know, please unmute yourself and tell me.
Glen, a square plus a square plus 2ab plus
Stop.
Glen, a square plus 2ab plus bc square.
BC square. You go to sleep, go. Good night. You are telling the answer, but you are telling B from where BC square is come. Who else knows? Can anyone else tell me what is a plus b the whole square?
Then
Yes, Dheeraj. Yes,
a
Dheeraj.
square plus 2ab plus b square.
Yeah, so easy. A square plus 2ab plus b square. This first term square plus 2 multiplied by a multiplied by b plus the second term square. We will practice a lot of formulas today. I thought today I will be free, but unfortunately leaving Dheeraj, others are going to be very busy. So yes, let's continue. Let's open the bracket here. So we get x square plus 2ax plus a square. Same way how I got here. A square plus 2ab plus b square. I get x square plus 2ax plus a square. Now if we compare the left hand side and the right hand side, just compare the left hand side and the right hand side. Compare the x term here and compare the x term here. What is the coefficient of this term? 2. And what is the coefficient of this term? 2a. Why I say 2a? Because apart from x, what is there? That is called as the coefficient. Okay, I hope you'll understand. Apart from x that is there is this. That is the coefficient. And apart from x, what is there is 2. So here 2 is equal to 2a. We are equating both, no? That's why we write equal to here. 2 is equal to 2a. And let us compare this k also. Third term is what here? K. And what is the third term here? A square. Okay, so let's solve this. Now 2 is equal to 2a. So therefore, if you see here 2 and 2 gets cut, what is a equal to? Nothing but 1. Now if a is equal to 1, so k will be nothing but equal to 1 square, because a is already we got 1. So k is equal to 1 square, therefore k is equal to 1. So we have got our third term here, k is equal to 1, and we have got a is equal to 1. Now we equate our old third term. What was the old third term? Minus 5. So what is our step? Please write it down. Adding and subtracting our third term. What we got as a third term? 1. Why we do adding and subtracting now? Very important question. Let me just do it in the sum, then I will tell you why adding and subtracting. What was the original question? X square plus 2x. Now the third term, what we got new? 1. So we add and we subtract. And what is our old third term? Minus 5 is equal to 0. Now this is our extra what we have written here. Why have we written here plus 1 minus 1? This is also mathematical summation. Why it is called mathematical summation is because in math we are not randomly allowed to add on one side of the equation, that is either left hand side or right hand side. We are not allowed to just put a number. Now suppose the equation was x square plus 2x minus 5 equal to 0. You just randomly can't put plus 3, minus 5, 2 minus, all these numbers randomly you just cannot put. You have to have some logic before putting it. Now what logic have we applied here? You might think, okay, we need logic, but what logic we have applied here? If you see, this is plus 1 minus 1 and plus 1 minus 1 is nothing but 0. So this doesn't change your equation. This doesn't change your equation. When I say plus 1 minus 1, that means your equation remains as it is what was in the question. X square is there, 2x is there, minus 5 is also there, and I only add plus 1 minus 1, which is nothing but 0. Okay, and why I am doing this plus 1? To find our third term. We have still not got our third term. We have done an assumption of our third term that is equal to 1, but we have to still find it. Okay, so let's solve this now. X square plus 2x plus 1 minus 1 minus 5 is equal to 0. Now if you see this part, this can be solved. Okay, only this part. This is nothing but, if you see, x square plus 2x plus 1 is your product and 2 is your sum or difference. So we can think of two numbers. Only see this equation. I'm talking. Only see this equation. We can think of two numbers. When we add or subtract, we should get 2, and when we multiply, we should get 1. What are those numbers? 1 and 1. 1 multiplied by 1 is equal to 1, and 1 plus 1 is nothing but 2. Okay. So this equation, if we solve, now you have the freedom to write directly the answer. You don't need to do factorization for the entire stuff. Directly you can write the answer. Now I'll just show you all how we get the answer. X square plus 2x equal to 1. So therefore x square plus, now both our factors are 1 and 1. So 1x plus 1x plus 1 equal to 0. Common in these two. X is common, uncommon. X plus 1. Again we write x plus 1. We have nothing but 1 we get equal to 0. Let's check. X into x square, x into 1, 1x, 1 into x, 1x, 1 into 1, 1. So therefore, common in these two is x plus 1 and uncommon is this x and this plus. X plus 1 into x plus 1 is equal to 0. Now x plus 1 into x plus 1 means it is repeated. So we can write this as x plus 1 the whole square is equal to 0. Did you understand? It is repeated twice, so that's why I wrote x plus 1 the whole square. So directly, if you don't need to solve this, you don't solve this. You have to solve it in your working column. Here you don't need to do the steps. You can directly write x plus 1 the whole square. This is the answer of this. X square plus 2 into x into 1 is 2x plus 1 square. Then after this, what we get? What is minus 1 minus 5? Minus 6 is equal to 0. Now let's bring this 6 on the right hand side. So x plus 1 the whole square is equal to 6. Now taking square root of both sides, we get what? Square root of x plus 1 the whole square, the square is gone. X plus 1 is equal to plus or minus root of 6 because we don't have a square root. So now I am doing the remaining part here. We are almost done with the sum. So x is equal to plus or minus root of 6. This plus 1 comes on the right, become minus 1. You get two answers. Therefore, x is equal to root 6 minus 1, or x is equal to minus root 6 minus 1. Plus or minus, no? So plus root 6 minus 1 minus root 6 minus 1. This is our sum which gets finished. Okay, let me just revise the sum once again. This sum can come for either 3 marks or 4 marks for you. Very easy to do if you practice. You need little practice for this sum. First, what we have to do is check if it is general form. Okay, can everyone hear me clearly? Please type a yes or no. You can hear me clearly. Please type a yes or no. Okay. Let me just revise the sum once again, then I will take all the doubts, whatever you have. X square plus 2x minus 1 equal to 0 is already in standard form, so you don't need to make it. Then this minus 5 is our third term. This is not matching with our sum, so we take it off for some time and we assume k to be our third term. And as we said in the third step, we have to equate this to x plus a the whole square. In every sum, this is standard, x plus a the whole square. Nothing changes. Okay. So x square plus 2x plus k, we open the bracket here, x square plus 2ax plus a square. Let's equate this. 2x here is 2ax and k is equal to a square. Cancel 2, we get a is equal to 1. And if a is equal to 1, substitute here. 1 square, so k is equal to 1. Once you get the value of k, adding and subtracting. Why we get adding? Why do we do adding and subtracting? Because it can be equal to 0. It doesn't change the meaning of our question. So the original question was what? X square plus 2x. This is not matching. So in place of minus, before minus 5, we put plus 1 minus 1. From where we got this plus 1 minus 1? The value of k. Now, the first three terms, we equate by factorization, we get x plus 1 the whole square. The last two terms, minus 1 minus 5 is minus. After this, square root of both the sides. X plus 1 is root 6, then plus 1 comes on the right hand side. We get minus 1 plus and then minus. Anyone has any doubt? Please raise your hand.